So in this video, we're going to talk about how to use regressions and Desmos to write linear functions and make predictions from a set of data. So when you plot data points on a grid, the resulting graph will be called a scatter plot. By looking at the pattern the data points in a scatter plot, you can draw in a trend line like this one shown here to represent the pattern that's in your data. Trend lines are considered to be a good fit or a bad fit depending on how well they represent the data in the graph. So, how do you find the equation of a trend line? You can actually find the equation of a trend line by performing what's called a linear regression in Desmos. And what Desmos will do is it'll actually give you the equation of that trend line. It'll also tell you a value called the correlation coefficient, which is represented by R, and that tells you how well that equation it gives you fits the data. If your correlation coefficient is closer to 1, that means your equation will be a good fit for your data. So the steps to performing linear regressions can be also found in the study guide that's posted in the resource folder. So make sure you're using that guide when you're working on your assignments. So let's start off with this example. Let's enter the data in this table into Desmos and go ahead and apply a linear regression to determine a function that best represents this data. So here's what we need to do. We need to first click on this plus sign for add item and then click on table. And then what we're going to do is we're going to type in this table exactly as it's given to us in the original problem. So I'm going to go ahead and do that now. And you always want to make sure and double check and verify that you've typed in everything correctly. And then what we're going to do is we're going to click this little add regression button that shows up right here. And then once you do that, it's going to go ahead and calculate a linear regression. You can see that as we're typing in the data points, it plots the scatter plot. And then when you do the linear regression, it'll give you the equation of the line and it'll graph it over your data points. So that equation that it gives us is y equals 2x plus 5. Notice here it also gives us the r value. It says r equals 1. And so that means that this line is actually going to be a perfect fit for our data points because you can see it passes through every single data point that's on our graph. So now you can go ahead and pause the video and try doing this example on your own. So here we have a whole new set of data, but it's going to be the same process as before. So you go to table and then you just go ahead and type everything in. And then once you've done that, you're going to go ahead and do add regression. And then the linear regression tells you the equation is y equals negative 5x plus 13. It says r equals negative 1. So this line is actually going to be a perfect fit for this data. So now let's look at this example. It says that Artemis works as a computer graphics artist for a major video game manufacturer. He's paid a monthly salary of $3,350 and he earns a bonus of $200 for each frame model he produces. The table shows the amount he earns in a month depending on the number of models he produces. Using Desmos, determine a regression equation to model this data. Okay, so let's go ahead and type in all our values. So once again, go to plus and then table, and then let's type this all in. And so now we're going to click add regression and then do our linear regression. So it tells us the equation is going to be y equals 200x plus 3350. And it tells us the r value is equal to 1. So that means this line is going to be a perfect fit for our data. And notice here, I can't actually see my scatter plot or my line on the grid. And that's because I have larger values here. So you can always adjust the zoom in Desmos. And then if we scroll around, you'll be able to find your graph. So regression equations can also be used to determine future values in real life situations. All you need to do is write the regression equation as a function and then substitute the given value into the function. And this is actually a really important application of regressions. So now what we can do is we can use the equation that we wrote in this word problem we were just working on and figure out a value that's not included in our table. So you can see here it has the equation that we found, which is y equals 200x plus 3350. And it's asking us now, how much would he earn in a month if he produces 8 frame models? So what we can do here is we can click this button right here to the right of where it says equation. And what it will do is it says export a snapshot into the expression list. So it's actually going to write this equation for us here in the next row. And if we start to think about our equation as a function, right, instead of y, if we think about this as f of x, if we're trying to find the amount when he produces 8 frame models, we're really asking what is f of 8? And actually, Desmos will calculate this for us. All you need to do is go here, and instead of y, you're going to type f of x. Once you have f of x, you go to the next row, and then you type f of 8. And then what it will do is it'll go ahead and calculate that value for you. So he'll earn $4,950 in a month where he produces 8 frame models. So let's try another example. So here it says a meteorologist collected the following data on the amount of snow in feet for different elevations. Find the equation of the line of best fit and use it to predict the amount of snow for an elevation of 10,000 feet. I'm going to go ahead and pause the video and give you a chance to go ahead and type all these values into your table in Desmos. So you can see here I have my table of values. So I'm going to go ahead and click this add regression button on the left. And then you can see here I have my linear regression equation. So I'm going to go ahead and write that down. I'm going to round. So I have 0.002x minus 3.21. And we're going to click this button right here to the right of where it says equation. And then I'm going to go ahead and I'm going to replace that y with f of x. And in the next row right here, I'm going to go ahead and do f of 10,000. And you can see here it gives me about 16.4 feet of snow as my answer. So now you can go ahead and pause the video and try doing this example on your own. So one of the things you need to keep in mind when doing this problem is that it's a horizontal table instead of a vertical one like we're used to. So when you enter this in Desmos, the first row right here is going to be our X values, and those are going to go in the first column of this table. The second row right here is going to be the Y values, and those are going to go into the second column of this table. Okay, so make sure you keep these points in order as you go ahead and type them in Desmos. Like you can see, this first point right here is 18.5. So that's what I have in this first row in Desmos. So once you have the values all entered, go ahead and click add regression, and we're looking for a linear regression. So here it gives us an equation. So we have y equals 0.88x minus 10.49. Okay. And so what we need to do now is predict how many points you'll score if she plays for 20 minutes. So what I'm going to do is click this button right here. You can see here it gives me my equation, and I'm going to replace y with f of x. And then we are going to go to the next row, and we're just going to do f of 20. And so it's going to give us the amount of points here. So notice all these points are integer values. So I'm just going to round to the nearest whole number. And so she scored 7 points. So using regressions in Desmos, you can write a linear equation that best models a set of data. You can then use this equation to calculate values that are not included in your data set.